In the last video, we briefly touched on ways to identify minerals, and so in this video we're going to take a closer look at those techniques. So minerals are identified by these seven main characteristics. There's some other properties that we'll look at as well. But the first one is color, streak, luster, density, hardness, cleavage, and fracture. And so color is the easiest to observe. You literally just look at the mineral and tell us what color it is. However, some minerals have the same color as different minerals. They both could be clear, they both could be white, they both could be green, they both could be gold, like pyrite is fool's gold, and real gold look very, very similar in color. Some minerals can come in a bunch of different colors, even though it's the same mineral. So quartz is an example of that. It can come in clear, it could come in white, it could come in pink, it can even come in purple, and the purple is from small amounts of iron. And so quartz is over here. We have that clear color, a greenish blue, a pink hue, and a purple hue to it. Impurities in these minerals can cause the mineral color to be different. So impurities would be like having this trace amount of iron in it. Weathering can also change the surface of the minerals. So being exposed to water or other different natural things, whether sunlight, animals, they can also change the color of the surface of the minerals. So even though color is the easiest to observe, it's also the least reliable. Streak is a little bit more reliable, and this is the color of the powder of a mineral. And to determine the streak, you scrape the mineral across a porcelain plate. So this right here is your porcelain plate. And the plate is harder than many minerals, which causes a powder to be left on the plate. It's kind of like using sidewalk chalk on concrete. The streak will often, not always, have a different color than the color of the mineral. This is a much more reliable method to identifying a mineral because even if the color of a mineral can be different, the streak will always be the same color. Different minerals may also have the same color, so like the pyrite, the fool's gold, and gold, they can have different streaks. So for example, hematite and galena, they're both minerals, and they both have a dark gray color, and they can be identified as two separate minerals because hematite has a reddish brown streak, where galena will have a gray streak. Luster, this is the way that light reflects off the surface of a mineral. And so this table gives you a list of lusters and then what they actually look like. So it can be, these are non-metallic lusters. Metallic is one of the main lusters where it looks literally like a metal. And these are on the table a list of different non-metallic lusters. Adamantine is sparkly, so like our A here, those are sparkly. Earthy would be dull and clay-like, so like B. Pearly would look like a pearl, maybe like C. Resinous, it would look a little bit like tree sap. Silky has soft looking with long fibers, maybe right here. And vitreous looks glassy. So those are some, when you do your mineral identification lab, this is a good list of your non-metallic lusters to help you identify your minerals by. Density is how much matter is in a certain amount of space. Substances that have more matter packed into a given space have higher densities. All substances have characteristic densities, which does not depend on how much of a substance you have. So, like water has a density of 1 gram per milliliter. And so it doesn't matter if you have 5 gallons of water or 1 cup of water, the density will still be 1 gram per milliliter. And so to calculate density, we have this handy dandy formula, which takes mass divided by volume. So if we do a quick little example, let's say we have a mass of a mineral is 6 grams, and the volume of that mineral is 2 milliliters. We can plug that into the formula, which says density equals mass divided by volume, and our mass is 6, so that goes in for M, so 6 grams, over our volume for V, which is 2 milliliters. So 6 divided by 2 is 3, and the unit is grams over milliliters. Density often gets misused. The term density gets misused, and we talk about things being heavy versus light, and that's a term, those are terms dealing with weight, which is not the same as density. So just be careful about that. Hardness is the mineral's ability to resist being scratched. Minerals are not easily scratched are called hard minerals. Minerals that are easily scratched then are soft. To test the hardness by scratching, you can either take a mineral to your unknown mineral and try to scratch it, or you can scratch your unknown mineral on a known mineral's hardness. And so remember from the last video, we have this hardness scale called Mohs hardness scale. And that's over here. And this scale gives you a list of known hardnesses and the minerals that are associated with that hardness. So talc is our softest mineral. It has a hardness of 1, so soft is at the top. And diamonds are our hardest mineral with a hardness of 10. Gypsum we talked a little bit about, remember that makes our sheetrock, is a fairly soft mineral, and that only has a hardness of 2, and that kind of makes sense if you've ever seen holes in sheetrock. You can pound a nail into it. Calcite has a hardness of 3, fluorite a little harder with a hardness of 4, apatite has 5, feldspar is 6, quartz, remember quartz is a component of sand, has a hardness of 7, topaz has a hardness of 8, corundum has a hardness of 9, and like I said, our hardest mineral is a diamond with a hardness of 10. Cleavage and fracture, again, deal with how minerals break. Cleavage is the tendency of a mineral to break along certain planes. And by that I mean they have nice geometric predictable breaks. See how in the first one it has smooth surfaces on those breaks. We have the nice clean, you can see that it would be like a rectangle or a cube. Again here on this purple one you can see the nice clean break patterns. On this middle one it's a little harder to see because the clean breaks are along this vertical plane here. Think of this as like post-it notes stacked on one another. And so it's a little harder to see there, but it is also an example of cleavage. Cleavage will have various shapes like polygons, but they're very geometric shapes. People who cut gemstones will follow the cleavage planes because it's a way to get the light to best reflect off of the different surfaces. Fracture is the other way that minerals can break, and this is breaking without any pattern. They're very uneven, it's jagged, it's not flat. The mineral could splinter like wood, and that could maybe be a fibrous type of fracture. So notice here in the diagram, there's no, this edge is kind of straight, but notice overall it's kind of got that round, there's just no predictability where that mineral will break next. So then we have some other identifying characteristics that are unique to certain minerals. So things like magnetism, reactivity, smell, they all are unique to certain minerals. So we can help narrow that down when we're identifying minerals. So like fluorite has the ability to glow or fluoresce under ultraviolet light. Magnetite is magnetic. Uranite is radioactive. Calcite will, if you kind of use your fingernail to scratch a little powder of calcite and then put a little acid on it, it will bubble and fizz, kind of like the baking soda and vinegar reaction. And then some have a distinct smell. That would be kind of sulfur. Sulfur is a mineral that has that distinct rotten egg smell. And so these are color, streak, luster, density, fracture, cleavage, and these other characteristics are all ways that mineralogists use to identify minerals.